Quite a sight in the Sahara Desert. One of the driest places on Earth has flooded.
The Sahara Desert, the world's largest hot desert, has recently experienced a rare and extraordinary flood event. Known for its arid conditions and scorching temperatures, the Sahara is not a place typically associated with heavy rainfall. However, this event shocked meteorologists and scientists alike. Floodwaters swept across parts of the desert, inundating regions unprepared for such a phenomenon. The Sahara spans 9 million square kilometers, and some areas receive less than 20 millimeters of rainfall annually. Yet, during this flood, rainfall exceeded 100 millimeters in a single day in certain locations. This sudden deluge disrupted the delicate balance of the desert ecosystem. The event has sparked urgent discussions about the role of climate change in creating extreme weather patterns, even in the most unlikely places. The Sahara stretches across 11 countries in North Africa, including Algeria, Chad, and Sudan. It is known for vast sand dunes, rocky plateaus, and intense heat. Temperatures can soar above 50 degrees Celsius, while rain is scarce and inconsistent. The desert's arid conditions result from subtropical high-pressure systems that prevent moisture from reaching the region. When rain does occur, it is typically light and quickly evaporates. However, the recent flood defied these patterns. Heavy rain overwhelmed the desert's natural drainage systems, causing water to collect in low-lying areas. The Sahara's unique geography, including large basins and valleys, exacerbates the impact of such rainfall. Water flows rapidly across barren terrain, causing flash floods. This highlights the region's vulnerability to extreme weather events despite its harsh climate. The flood was primarily caused by a rare weather system that brought heavy rain to the region. Meteorologists attribute this to a combination of atmospheric instability and rising global temperatures. Climate change is intensifying weather patterns, increasing the likelihood of extreme rainfall in arid regions like the Sahara. Anomalous atmospheric rivers, a phenomenon where concentrated moisture flows through the atmosphere, likely played a role. These systems transported moisture from the Atlantic Ocean to the desert, resulting in unexpected rainfall. Human factors also contributed to the flood's impact. Decades of deforestation and overgrazing have degraded the desert's soil, reducing its ability to absorb water. The combination of these natural and human influences created the perfect conditions for a catastrophic flood. The floodwaters swept through desert regions, leaving destruction in their wake. Roads, makeshift settlements, and agricultural land were submerged. Several communities reported damage to infrastructure, including water wells and shelters. The flood disrupted daily life for nomadic tribes and desert inhabitants. Reports from Sudan and Chad highlighted that thousands of people were displaced. Crops were washed away, and livestock drowned, threatening the livelihoods of local populations. Wildlife was also affected. Desert species, adapted to survive with minimal water, faced habitat disruption. Flash floods buried burrows and drowned smaller animals. Satellite imagery revealed large water pools where there had previously been sand dunes. These ephemeral lakes could last for weeks, but their immediate formation underscored the unusual scale of this flood event. Flooding temporarily transforms the desert into an oasis-like environment. The sudden appearance of water bodies created opportunities for flora and fauna to thrive. Seeds dormant in the sand germinated rapidly, bringing a green tinge to the desert landscape. Ephemeral lakes and rivers provided drinking water for animals, enabling wildlife populations to flourish briefly. Birds, including migratory species, took advantage of these temporary water sources. However, not all effects were positive. Floods washed away fragile topsoil, making some areas more prone to erosion. Aquatic organisms, such as fish and amphibians, may have been introduced to the region via flooded rivers. This could disrupt local ecosystems. While floods bring a temporary resurgence of life, the long-term impact depends on the frequency and intensity of such events. Rare floods like this have lasting effects on the Sahara's geography and ecosystems. The influx of water recharges underground aquifers, which is crucial for arid regions. These natural reservoirs store water that supports life long after surface water disappears. The flood also reshaped the desert landscape. Erosion created new gullies and altered sand dune formations. These changes could impact how future rainfall is distributed. Vegetation growth following the flood may help stabilize some areas. Long-term ecological shifts are possible if such events become more frequent. Species that thrive in wetter conditions could expand their range into the desert. However, the destruction of habitats may force some species to migrate or face extinction. The Sahara's future could depend on how its ecosystems adapt to these changes. The flood had significant consequences for people living in and around the Sahara. Nomadic tribes, who rely on the desert's sparse resources, faced immediate challenges. Livestock losses and damaged water sources disrupted their traditional way of life. Emergency responses included the distribution of food and medical aid to affected areas. Governments and NGOs worked to repair infrastructure and provide clean drinking water. However, the remoteness of many regions made relief efforts difficult. Long-term planning is essential to mitigate future impacts. Strategies include building flood-resistant infrastructure and restoring vegetation to improve water absorption. Education and training programs can help communities adapt to changing weather patterns. Investments in monitoring systems and early warning technologies are also critical for preventing loss of life. The Sahara flood is a stark example of how climate change is altering weather patterns. Rising global temperatures increase the atmosphere's ability to hold moisture, leading to more intense rainfall events. This phenomenon is especially noticeable in regions previously considered arid. Studies show that extreme rainfall events have become 25% more frequent in the past 50 years. Climate models predict this trend will continue, particularly in deserts like the Sahara. Increased rainfall could bring both opportunities and challenges. While floods may temporarily replenish water sources, they also highlight the unpredictability of a warming planet. The Sahara flood serves as a reminder that no region is immune to the impacts of climate change. Global efforts to reduce emissions and adapt to new weather realities are urgently needed. Flooding in the Sahara is not a new phenomenon but has always been rare. Geological evidence suggests that the desert was once a lush, green region with abundant rainfall. Known as the Green Sahara, this period occurred roughly 5,000 to 10,000 years ago. Ancient rock art in Algeria's Tassili en Adja region depicts rivers, lakes, and wildlife, indicating a wetter climate. These conditions were caused by shifts in the Earth's orbit that altered rainfall patterns. Modern flooding events, however, different. Unlike the gradual changes of the past, today's floods are sudden and linked to human-induced climate change. Comparing historical and modern events highlights the importance of understanding natural cycles and human influences. Studying past climates may provide insights into the Sahara's future. The Sahara flood presents a unique chance for scientists to study desert hydrology. Researchers are analyzing water flow patterns, soil absorption rates, and the flood's impact on local geology. These findings will improve our understanding of how deserts respond to extreme rainfall. The event also offers insights into desert ecosystems. Scientists are studying how plants and animals adapt to sudden changes. This research could inform conservation strategies for arid regions. Satellite technology is playing a crucial role in monitoring the aftermath. Data from these tools helps track how water bodies evolve and disappear over time. Understanding these processes is vital for managing resources in arid environments. The Sahara flood also underscores the need for international collaboration. Scientists from multiple disciplines must work together to study such complex events. Their findings will help prepare for future challenges in deserts worldwide. The Sahara Desert flood holds critical implications for understanding global climate dynamics. While the Sahara is one of the driest places on Earth, extreme weather events like this flood indicate how interconnected global systems are. The increased frequency of unusual weather patterns, even in arid regions, reflects the broader impacts of climate change. Deserts like the Sahara play a role in regulating Earth's climate. Dust storms originating here influence weather and nutrient cycles across continents. Floods in these regions disrupt this balance, potentially altering global atmospheric circulation. This event also highlights the need for global cooperation. Countries must share data, resources, and strategies to mitigate the effects of climate change. Studying the Sahara flood provides lessons for managing water resources and extreme weather in other vulnerable regions.